This is the last part of Good Morning. This is the last part of chapter 25. We are going to talk about image forming by mirrors. And of course, here, this is due to reflection because light, when it hits the mirror, is going to reflect. This type of mirror, when we have this, is the reflective side here. We call it concave, and that one is convex. We're going to see that for the concave, the type of the image is going to depend on where the object is located. Here we are going to find for the convex that is going to be only one case, and we're going to see how really these are really done. Now, the first one, it is when I have the object is sitting at a distance greater than r. Now, what does it mean r? R is the radius of curvature. It is from here to here. Halfway, we're gonna have the focal point of the mirror. Then this one is a concave mirror. And C, it is the center of the sphere where, like the center of the sphere that this mirror was formed from. R, it is from C to the here to this point. F, which is the focal length of the mirror, is going to be halfway between C and this point. Now, always, I'm going to represent my object by having that kind of arrow. This is the green one. Okay, now the rules here for the spherical mirrors is the first light, you're going to have it parallel to the principal axis, and then it will reflect through the focal point. Now, the second beam of light is going to go through the center, and it will reflect on itself. They are going to intersect here, and therefore, this is really the head of the, the head of the image. And you can see, again, based on the definition that we said last time, when the image is going to form from on the same side as the reflected light, we call it real image. It is very clear that it is reduced and it is inverted. One more thing I want maybe to introduce here is magnification. Magnification is either defined as the length of the image divided, or the height of the image divided by the height of the object. Then this is the image's height, and this one is the object's height. Or, and we use for it lowercase m. Okay, m also can be actually defined as, let me just say, when I use the same notation, okay, it's going to be minus v, which is the object's image's distance divided by u. This is the image distance. Okay, and that one is the object's when the magnification is negative, the object, the image is inverted. And when the magnification is plus, the image is upright or erect. Okay, let me show you, like here, I did show you using a diagram, how really the image is forming. Now I'm gonna show you using the calculation. I'm gonna use the same numbers that I have in the, because I have here squares. First, okay, let me have this cut off because I don't wanna scroll up and down. I'm gonna have it transferred with me. I'm gonna have it here. Good. Okay, and then I'm gonna add another page. Here U is the object's distance, and it is actually the distance between the object and the mirror. And here, if you look, if I will calculate how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's about 9.5, let's say centimeters, 9.5 centimeters. Okay, it will not make a big difference because, because my case is going to be verified that the object is sitting at a distance greater than r, then, it's going to be the same. All right, now here r, which is the radius of curvature, of the mirror, it's about 1, 2, 3, 4, 5, about 5. The focal length, it is r over 2, which is 5 divided by 2, and that is 2.5 centimeter. Now, for a concave mirror, R and F are both positive. All right? Now the equation, it is 1 over U plus 1 over V equals 1 over F. I wish to find where is my object's, my image's position, and therefore I need 1 over V. Then I'm gonna say 1 over F minus 1 over U. Okay, F, it is 2.5 centimeters. And U is, we said, 9.5 centimeters. Now let me show you how we're gonna use the math here. For the math, I'm gonna say 1 over 2.5, it is 0.4. And 1 over 9.5, it is 0.105. Okay, then I'm gonna subtract these two numbers, and that is gonna be 0.295 centimeter minus 1. I need V, therefore I'm gonna say I wanna take 1 over this number, okay? And that is 3.39 centimeters. Okay, let's look at this, like here, it's almost, okay? Like this is 1, 2, 3. It's very close to what because remember, our distances are really approximated. Now the magnification, we said, is gonna be negative V over U, and therefore it is negative 339 centimeters by 9.5 centimeters. And you can see it is gonna be less than 1. Okay, it is first negative because the object, the image is inverted. It is less than 1 because the object is reduced. And of course, it is real because it is forming on the same side as the, what is called, the reflecting light. All right. Now, let's move to the next case. Now, the next case, we can actually say, okay, let me show you one more case, not this one. I want to show you when the object is sitting at, okay, let me have this. I want to have this when it is sitting at a distance that is going to be equal r, okay? So that you will see what type of image I'm going to expect. Okay, here, of course, this is a concave mirror. Okay, therefore, okay, this is the painted wall, the painted here. All right, I can also get rid of this part. Okay, and then here, this is my principal axis almost, and here is my, let's say C. My F is gonna be here, and then I will here see this is my, okay, my object. I'm gonna get, this is my first beam, is gonna reflect through this. The second one, I'm gonna make it go through the focal point, and therefore is gonna be like, okay, my drawing is not exact, okay, because I did not use a ruler, and therefore this is, look here, this is my image, and here also it is real, but it is same size, and also it is inverted. Okay, as we keep on bringing the, the object closer to the mirror, the image is going to be larger and larger, and then when it is at the focal point, no image is going to form, and then after that, the image is going to be virtual, enlarged, upright. If you look at it, here, this is the image. Now here, R is going to be negative if I want to use the formula, and F also is going to be negative. Now for the convex, the convex, I told you it's only one case, and that is really here. We have it virtual, reduced, and upright. Here is the equation showing you again. U is the distance between the object and the mirror. V is the distance between the image and the mirror. And R is the radius of curvature of the mirror. And I can write the equation either in this way or this way. F, it is positive for concave, and it is negative for convex. Here I'm again solving another problem with U, where R is 8 and U is 10, and I, again, for a concave, 1 over U plus 1 over V equals 1 over F. and then I have calculated V, and then this is really the magnification. Let me use the same notation, lowercase m. Okay, it's the same idea. I think I don't want to make the video very, the file very big, and therefore I'm gonna stop here. I'm gonna cover the lenses in another video. Okay, thank you.